This is a science class in case we are being confronted with a scenario like this. A student dropped a bar magnet and an empty bottle in the water simultaneously. He realized that the bar magnet sinks while the empty bottle floats. How will I explain this to grade 7 child? Now, we know that matter, as we say, a mass, we compare them, we look at the mass of this object. If this is the bottle, and this is the bar, a piece of bar magnet, obviously you drop them in water, a child would think both to float or both will sink. Science explained that. Let's compare the mass of this, or we call a mass of a body is a quantity of matter that body contains. So let's go and take the mass of this bottle with in a lab, since we're in a lab. Now, with assumption that this is an electronic balance, I gently put my bar magnet on it, and when I plug it, it reads. I drop it, I record it. I drop a piece of Bell Cola bottle on it, and it reads. I drop it. Now, I go and find the volume of respective objects. Now, let's come to the board. If an assumption, the electronic balloon recorded 800 grams as the mass of the bar magnet, and the volume occupied by this, since it's a regular shape or this is a rectangular shape object, can be calculated by what? Looking at the length multiplied by the breadth times the height. This is the length, this is the breadth, this is the height, as it is a 3D shape. Now, when an assumption is taken, if you have this is centimeters, and the standard measurement in volume is meters. So you change it to meters times 0.2 meters and 0.15 meters. If you multiply all, you are about to get what? 0.009 cubic meters. Now you compare, this is the volume, this is the volume it occupies, this is the mass it occupies. Let's compare the volume, the mass per the unit volume of the bar magnet. We call it a science, we call it what? Density. Mass per the volume of this object. Quickly, this is, you compare this to kilograms. Standard unit give you what? 0.8 kilograms. So you measure here, this will give you 0.8 kilogram. Since this one, it converted to meters, it will give you simply 0.09 cubic meters. If you convert all, you are bound to get, let's do the calculation. You get 8.89 kilogram per cubic meter. Now let's come to the mass. Assuming that the mass of the empty bottle was what? 10 grams. Since it's not heavy, it is 0.01 kilogram, and the volume occupied by a cylindrical object is pi r square h. Since it's like a cylinder, this is how you will get it. This is a radius, this is a pi. If you substitute everything, the radius is given object is given us to be 0.3 meters. If you substitute all with this equation, 0.3 is a meters, this is the height, this is a meter. If you substitute, you get 0.047. You compare the mass and the volume, you get a value of 2.29. Now, the density of the magnet is 8.8 kilogram per cubic meter, and the density of the bottle is gotten what? 0.0478 kilogram per cubic meter. Now, in a nutshell, there are differences here. We know that the lesser object floats and more heavier object what sinks. The respective density check, where this is higher than this. So it confirms the point that the magnet is likely to sink whilst the bottle is likely to sink. Let's look at empirical evidence. Empirical evidence. If you drop this magnet in any object, it will sink. No matter what, it will sink. If you drop the bottle, since the density is less, it will surely float. Now, this concept is used to explain why ships float in water and why objects are sinks and why objects even float in the air. On this concept, we call it a daytime soma. So a child should know that because of difference in density, that's what happened. Thank you.